Champ. Term Book. Class 5th. Second Term.
Science. Chapter 3. Our Life Supports. We know that air is all around us. Without air, life is not possible on Earth. The blanket of air around the Earth is called the atmosphere. Air is a mixture of gases. It occupies space. Air is very useful for human beings as well as other living beings. Human beings and animals breathe in oxygen and give out carbon dioxide. Lighting of fire also requires oxygen. Plants take in carbon dioxide and give out oxygen during photosynthesis. Troposphere. This is the lowest layer where we live and where almost all weather occurs. It contains the most air, and the temperature gets colder as you go higher. Stratosphere. Located above the troposphere, this layer contains the ozone layer, which protects us by absorbing harmful ultraviolet, UV, radiation from the sun. The temperature here increases with altitude. Ionosphere. A region of charged particles that overlaps other layers. It is very important for communication because it reflects radio waves back to Earth. It is also where beautiful auroras, northern, southern lights, occur. Exosphere. The outermost layer that gradually merges into space. It is extremely thin, and this is where satellites and the International Space Station orbit the Earth. 1. Composition of air. Air is a mixture of gases that surrounds the Earth. Its composition by volume is nitrogen, 78%, the most abundant gas, essential for plant growth. Oxygen, 21%, vital for the survival of humans, animals, and for combustion, fire. Other gases, 1%, includes argon, carbon dioxide, helium, and traces of others. 2. Moisture in air. Moisture, or humidity, refers to the amount of water vapor present in the air. It comes from the evaporation of water from oceans, lakes, and rivers. When air is heated, it can hold more moisture. As air rises and cools, this water vapor condenses to form clouds and eventually precipitation, rain, snow. 3. Air exerts pressure. Although we cannot see it, air has weight and exerts pressure in all directions. Atmospheric pressure. This is the force exerted by the weight of the air column above a specific point. Altitude impact. Air pressure is highest at sea level and decreases as you go higher, e.g., on a mountaintop, because there is less air pressing down from above. Everyday examples. We use air pressure in daily life, such as when using a suction cup to hang items or using a straw to drink liquid. 1. Prevention of air pollution. This section focuses on reducing the pollutants that enter the atmosphere. The strategies include cleaner energy, using renewable sources like wind and solar power instead of fossil fuels. Reducing emissions, installing filters on factory smokestacks to trap particulate matter before it is released. Sustainable choices, planting trees to absorb CO2 and using public transport or electric vehicles to reduce transportation emissions. 2. Removing insoluble impurities, filtration. This is a physical process used to separate large, undissolved particles from a liquid. As shown in the diagram, dirty water is poured through a funnel containing layers of filter media, like sand and gravel. These layers trap the solid debris, allowing clean, filtered water to pass through into the beaker below. 3. Sedimentation and decantation. These are sequential processes for separating mixtures based on gravity. Sedimentation. When a mixture, like muddy water, is allowed to stand undisturbed, the heavy, insoluble particles, sediment, gradually sink to the bottom due to gravity. Decantation. Once the sediment has settled, the clear liquid above it is carefully poured off into another container, leaving the solid particles behind. Filtration. This is a physical process used to remove large, insoluble impurities, like sand, dirt, and debris. Dirty water is poured through a porous material, like layers of sand and gravel in a funnel, which traps the solid particles but allows the clean water to pass through. Evaporation. This process is used to remove soluble impurities, dissolved solids, like salt. The saltwater solution is heated until the liquid water turns into steam and evaporates, leaving the solid salt crystals behind in the container. Distillation. This is the most complete purification method. It combines evaporation and condensation. The impure water is boiled to create steam, which is then collected and cooled in a condenser, turning it back into pure, liquid water in a separate flask. This process effectively separates both soluble and insoluble impurities.